Okay, welcome back. Continuing our tension problems. We're looking at another problem. This one's actually called an Atwood device, after the professor who worked on it. Essentially what we have is we have a pulley system with two masses that are connected by a string. And we would like to find, like our other tension problems, acceleration. And let's find the tension that is in the rope there. First step of the problem, you want to identify forces that we see. And so the 5 kilogram blocks is being pulled down by the force of gravity. Force of gravity is mass times the gravitational acceleration, which equals 5 kilograms times 9.8 meters per second squared. So this is equal to then pulling down on a force of gravity 49 newtons. The 8 is pulled down by the force of gravity, and that also would be mass times gravity, so that would be 8 times the 9.8. Shortcutting ourselves a little bit. I think probably should still have units there. It's better to work with units. In case you make a mistake, your units will tell you that to what you have. So 8 times 9.8 gives you 78.4 newtons. Okay, that's all the forces that are there. So for finding acceleration, I need to do the summation of force equals mass times acceleration, Newton's second law. Well, I need to make my prediction. At this point, before you start solving, we need to try to have an idea of which way we think it will move. It looks like with more mass that this will actually move in this direction. So it'll move to our left, which we are going to call our positive direction. So everything moving in that way is positive. And so the 8 is being pulled down by the force of gravity. Since down is in the same direction as that movement, we'll have a positive 78.4 newtons. And this is going to be pulled back by the force of gravity on the 5, which is 49 newtons. Now this is being pulled the opposite direction that it's moving, so that would be minus, and that equals the combined mass. So 8 plus 5 kilograms times the acceleration. And so the acceleration of this system would be 2.26 meters per second squared after you do it on your calculator. There is a shortcut of this problem. If you do realize that breaking down this work, I'll do it over here, it was 8 times 9.8 minus 5 times 9.8 equals our combined mass, which I can just do is 13 now kilograms times A. Well, you could have subtracted this before and kind of just done 3 times 9.8 equals 13 kilograms times your acceleration. And you would get the same answer. Okay, so that's kind of a math shortcut. Once you see it, you're more than welcome to use that. Tension. I do need to find tension still. So for tension, I need to split. And I could then look at the left or the right. So tension here. Let's look at the left side here. For no other reason besides I chose left. First thing I want to do is sum the forces just on the left side. And so this 8 kilogram box is being pulled down by the force of gravity at 78.4 newtons. That is in the same direction that it's moving, so that is positive. It is being pulled up by this cable, which is where the tension is. That's minus the force of tension, is equal to the mass of just the 8. We've isolated, so I only look at that one thing now. 1 kilogram times the acceleration. So what is the acceleration of that box? Well, we just found it here. That box is accelerating down at 2.26 meters per second squared. Just so we are clear, you'll see some other problems, that this one will be moving up at this acceleration rate. And so our acceleration is 2.26 meters per second squared. Now some people ask, well, why didn't I make those negatives? I call this direction positive. This one is moving down, so it is accelerating down in the direction that I call positive for this problem. So you want to keep with that. Now it's time to do math. 8 times 2.26 minus 78.4 divided by -1 gives you a tension of 60.3 newtons. Remember, this problem has its inherent check. If you wanted to solve the other side, say this side, we could do that real fast. We'll sum the forces. Tension is up in this case, so that'd be positive tension minus 49 equals the mass of 5 times the acceleration of this block. And this block is accelerating in the way that it's moving, so 2.26 meters per second squared. This is kilograms, and that was newtons. Which also gives you the same tension, because tension's equal and opposite on both sides. Okay, Atwood's problem. Very simple. Hopefully you understand. If you have any questions, always please go ask others or replay the video and look at it more. Hope to see you again in the future. Bye.